Chapter 3, Unit 2, Part 3, Characteristics of the mean. Changing the value of any score in a distribution changes the value of the mean. Introducing a new score or removing a score also changes the mean, unless the score you add or remove is exactly equal to the mean, which is very uncommon. Adding or subtracting a constant from each score changes the mean by exactly the same constant. Multiplying or dividing each score by a constant multiplies or divides the mean by that constant. So let's look at changing a score the long way. So here you have a sample of quiz scores for a psychology lab section that consist of 9, 8, 7, 5, and 1. Find the original mean and then change the score of x equals 1 to x equals 8 and find the new mean. Well, finding the original mean, you would list the scores in a row. You would find summation of x. In this case, you would find 30. Then you would find n. There are 5 scores here, so n equals 5. The third step would be to find the mean, which is summation of x over n, which would give you 6. Part 2, let's find the new mean. Well, list the scores in a table format. So this time, instead of a 1 as the last number, make it an 8. And then you would find summation of x now is equal to 37. There are still 5 scores, so n is still 5. Step 3, find the mean, which would be 37 divided by 5, which would give you 7.4. Notice that because one of the scores went up, it went from a 1 to an 8, that the mean also went up. So the original mean was 6, the mean is now 7.4. So if you change a score and the new summation of x is much higher, that means the new mean is going to be higher. So changing a value typically influences the mean. Now let's use the shortcut. This is what we'll be using in this class. A sample of quiz scores for the psychology lab has the same exact problem as the one we just talked about, and the work for finding the original summation of x is on the right. You'll see that the original summation of x was 30. So now, for the new shortcut, we have to realize that changing from a score of 1 to a score of 8 is a difference of plus 7. And the way we find this is we say new minus old. The new score is 8, the old one was 1. That's a difference of 7. Because 7 is positive, this means that 7 points are going to be added to the original summation of x of 30 in order to find the new summation of x. So the new summation of x is equal to 30 plus 7, which is 37. You know there are still 5 scores. The new mean is 37 divided by 5, which is 7.4. This also works if a score is lowered. You would have points subtracted from the original summation of x. You would still use exactly the same process. Let's talk about adding a score into a sample. So suppose you have a sample of n equals 5 and the mean is 7. I want you to find the new mean if a score of 13 is added to the sample. Okay, we're going to use the short way again. So the first step is to find the original summation of x. You know how to do this. N times m, which is 5 times 7, which is 35. Step 2, find the new summation of x. Well, the original is 35, and now we're adding 13 more points to it. So the new summation of x is now 48. Step 3, find the new n. Well, there were originally 5 in the sample, and we added a new one. So now there is 5 plus 1, or 6. So n is now 6. So now you can find the new mean. The new summation of x is 48. The new n is 6. Therefore, the new mean would be 8. And it's much easier if you sort of make a table on your paper and put the information about the original sample on the left and the new sample on the right. As you go along, you add things to your table. I usually do it in the same order. N is at the top, summation of x is in the middle, and m is at the bottom. All right, let's do removing a score example. So this time we have a sample with n equals 5 and a mean of 7, and we're going to remove a score of 11 from the sample. So the original summation of x here would be 5 times 7, which is 35. So, and I want you to fill out your table as you go along. So you would put in 5 and 7 and 35. And for n, you would put in 4 because now there is 4 in the new sample. Okay, so the new summation of x would be 35, which is the old summation of x, minus 11, because we're removing 11, would be 24. So now you put 24 as the new summation of x for the new sample. You find the new n, 5 minus the one that was removed is 4. You find the new mean, which is the new summation of x, which is 24, divided by the new n, which is 4, gives you a new mean of 6. Add this to your table. Adding or subtracting a constant to each score. If you add or subtract a constant value to every single score, say like a 2, then the same constant will be added or subtracted from the mean. So 2 would be added to the mean. So here's an example. These researchers found that reading times for material on a computer screen were quicker with warm color backgrounds than with cool colors when testing adults with dyslexia. Notice the warm colors on the 4 participants. Their score was 11, 12, 14, and 11. However, notice that 3 points were added to every single score when looking at cool colors. So the 11 became a 14, the 12 became a 15, etc. So let's look at what this did for the mean overall. So the mean of the warm colors was 12, the mean of the cool colors was 15. Notice that because we added 3 points to every single score, that the new mean is now 3 points above the original mean. So by adding 3 points to every score, this also adds 3 points to the mean. Let's talk about multiplying or dividing each score by a constant. This works in exactly the same way. So let's say on the left column here, we had original measurements that were in inches, so 10 inches, 9, 12, 8, and 11, and the mean of those was found to be 10. Well, say we wanted to convert it to centimeters, so we multiplied every single original score by 2.54, and this changed it to centimeters. And now the new mean is 25.40. So notice that by multiplying every single score by 2.54, this also multiplies the mean by 2.54. So the original mean of 10 multiplied by 2.54 gives you a new mean of 25.4. Let's look at removing a score example. So given a class with 9 students and say the test average was 72. Well, let's say that one student drops the class and he had a score of 98. What happens to the mean? Well, step 1, find the original summation of x, which would be 9 times 72, so this would give you 648. Step 2, you'd find the new summation of x, which is the old minus the 98 points from the student who dropped the class, so 648 minus 98 would give you a new summation of x of 550. Find the new n. Well, there were 9 students, one dropped the class, so 9 minus 1 is 8. Now we can find the new summation of x, which would be 550 divided by 8, which would give you 68.75. Notice that by removing a score that's higher than the mean, the new mean went down. So the old mean was 72. We took out a 98, which was a really high score. The new mean is lower than that. Here's a learning check. Go ahead and pause the problem and start the video back when you've figured out your answer. So a sample has a mean of 52. One person with a score of 48 is removed. What effect will it have on the sample mean? Well, let's think about this. The mean is 52. A person who was lower than 52 with a score of 48 is removed. Well, that means the mean will go slightly higher because it doesn't have that low score pulling it down anymore. So the answer would be A. The sample mean would increase. All right, learning check problem 2. Again, pause the video and then come back when you're done. So let's think about this. A sample of 4 scores has a mean of 10, and another sample of 10 scores has a mean of 20. If the two samples are combined, what value will be obtained for the mean? All right, so let's think about this logically. If both the scores had the same n, so like say n was 4 for 1 and n was 4 for 2, then the mean would be exactly in the middle. So the mean of 10 and the mean of 20, the mean would be 15, which is in the average, right? Can you see that? However, what happens here, the second sample has a lot more scores. So it has 10 scores. So it's going to pull the mean much higher because its mean is 20. So the mean is going to be closer to 20 than it is going to be to 10. So the mean is actually going to be greater than 15, which would be the average mean if n were the same for both samples, but it's going to be a little bit less than 20. So the answer would be B. Learning check 3. Pause the video. Okay, a distribution of 10 scores has a mean of 30. If every score in the distribution is multiplied by 3, what's the value of the new mean? Well, you simply multiply the mean by 3. So 30 times 3 would give you 90. Learning check 4. A sample of n equals 8 scores has a mean of 20. If one of the scores is changed from 4 to 12, what's the new value for the sample mean? Pause the video and work the problem. Step 1, find the original summation of x, which would be 8 times 20, which gives you 160. Step 2, realizing changing from 4 to 12 is a difference of plus 8 because new minus old equals 12 minus 4, which equals 8. Step 3, the new summation of x is equal to the old summation of x plus 8, so you get 168. Step 4, with 8 scores still, n is equal to 8. And the new mean would be 168 divided by 8, which would give you 21. Learning check problem 5. Pause the video and see if you can figure this out. So we have a sample of 7 scores with a mean of 5. 1 score is removed from the sample, and the mean for the remaining score is found to be m equals 4. What is the value of the score that was removed? So you're going to fill in your chart. You're going to put, for the original sample, you're going to put an n of 7 and an m of 5. And for the new sample, you know m equals 4. So fill in the chart with what you know. The next thing you can find is the original summation of x, because you know the original n, you know the original m. So summation of x is n times m, which would give you 35, so fill that in on your chart. The next thing we can find is n for the new sample. Well, we know that n was 7, but a score was removed, so now n is 7 minus 1, or 6. So now you know for the new sample, you know n and you know m. You can find the new summation of x, which is n times m for the new sample. So 6 times 4 would give you 24. So your chart should now be complete. Step 5. Now we're going to find the value of the score that was removed. We do this by saying new summation of x minus the original summation of x. Well, the new summation of x is 24. The original was 35. So that gives you negative 11. The negative indicates that a score was removed. So a score of x equals 11 was removed from the distribution. Learning check problem 6. A sample of 20 scores has a mean of 40. A second sample has n equals 5 with a mean of 30. If the two samples are combined, what value will be obtained for the mean of the new sample? So fill out your chart the best way you can. Pause the video while you do so. So in this problem, if you fill out for sample 1, n is 20, m is 40, you can easily find summation of x. 20 times 40 would give you 800. And then let's look at sample 2. N is 5, m is 30, so again you can find summation of x. 5 times 30 would give you 150. Finally combined, the total n would be 20 plus 5, which would be 25. The total summation of x would be 800 plus 150 to give you 950. And then to find the total m, you look at 950 divided by 25, which would give you 38. And that would be your new mean for the combined sample.